Okay, perfect. So welcome to the season 3 of the Aurora Technical Workshop for Pilot. I'm Juan Cano de Benito from the UPM, and today we will explain a little of the semantic adapters. The semantic adapters. We will talk about a little more of the semantic interoperability, present the semantic adapter concept. We will create a mapping and learn how to register this mapping. We'll see a demo of the semantic adapter and talk a little about the programmatic adapters. Just remember that the prerequisite for this session is fill the ontology requirements and read the RML documentation. Maria is working in the ontology requirements for the people that fill the ontology requirement. If you don't fill the ontology requirements, fill it, please, because we will need in the next sessions. So nowadays, we live in a world in which most device generates heterogeneous data source. For example, an IoT device generates large amounts of data in heterogeneous formats, but this presents a number of challenges. The first one, the heterogeneous access. Different companies or service have different ways for providing information. For example, database, APIs, files, URLs, among others. The second one is the heterogeneous format. This information can be expressed in different methods, as the information can be in different formats, such as JSON, CSV, XML, etc. And these formats can be expressed in different methods, in different ways. For example, in Aurora, two partners may have different JSON to represent the same information. What offers Aurora? Aurora offers the semantic interoperability solution, and the challenges of heterogeneous data source are solved. Data is exchanged transparently, and this is due to the semantic interoperability offered by Aurora. So let's talk about the Aurora infrastructure. The Aurora platform receives different data from different sources. This data can be expressed in heterogeneous format, follow any model, and can be accessed in different ways. To achieve the syntactic interoperability, the access, the format, and the model are homogenized in Aurora. For the model, we use SparkQL. For the format, we use RDF. And for the access, we use a REST service. Once the syntactic interoperability is accomplished, if the data is aligned to an ontology, well, a common ontology among all the platform participants, the semantic interoperability is achieved. So here you can see the Aurora node. And in this session, we will talk about the adapter. The adapter translates data from heterogeneous source into semantic data source. There are two types of adapters, the programmatic adapter and the declarative adapter. The adapters are chosen and deployed by the pilots, and each adapter has pros and cons. Here you can see how in this example, here is non-normative data that not support the semantic interoperability. The adapter is dedicated to convert this data to RDF in order to achieve the syntactic interoperability, and if the data is aligned to an ontology, the semantic interoperability. In this session, we will focus in the declarative translator. The first thing is what is RDF? Okay, RDF is data represented in typers. We need a subject, a predicate, an object. The subject is the resource, the predicate is the property of the relationship, and the object is the value or other resource. For example, a subject can be Bob, the predicate can be is interested in, and the object is the Mona Lisa. And at the same time, an object can be a subject. For example, the Mona Lisa predicate was created by the object Leonardo da Vinci. If you are interested in RDF, you have here a link, and here is the documentation, RDF documentation. So the declarative translator is the semantic adapter. The semantic adapter applies content enrichment to the theme description stored in the Aurora node, and the translator and translate heterogeneous formats such as JSON or CSV to W333 standards such as RDF. What is the key of the semantic adapter? The semantic adapter is declarative. We need a mapping, and the data is generated in RDF. The semantic adapter features are we have different methods for generating RDF: synchronous, asynchronous, and etc. Different data sources are supported, such as file, URLs, HTTP, and if the data is not supported, you can create custom plugins. And the supported formats are JSON, CSV, XML, Regis, HTML, among others. So, how can we create a mapping? Okay, imagine that we have a cow with a device that provides data in JSON. The first thing is defining the data source in the mapping. We need the ID, for example, cow data source. The handle is the type of the data provided by the component, in this case JSON, so the type is JSON handle. The iterator is the JSON path, and a provider. The provider is all the information requested by the component. For example, if we have an API, we need a user password and maybe an APK, an API secret, etc. And the second step is define the resource rules. In here, we put the subject, for example, in this case, the subject is the ID. So we put here the JSON path of the ID. The predicate is the name, and the object. The object is the path of the name of the cow. So there are a lot of properties, for example, altitude, country, time zone, coordinates, etc. And here you can see a complete mapping. Okay, but we will do an example of this. Okay, and use case. We have an Atmos device, a thermometer that generates data in JSON. So if we use the semantic adapter, we produce RDF data that is stored in the database. So we need a mapping to generate this RDF data. So what is the mapping? So let's do one little example here by okay. The Netatmo device generates this JSON. So the first thing is write the data source. The data source, the ID here is, for example, Atmo data source. We can add one parameter that is refresh. If we want to automatically refresh the data in the database, for example, in milliseconds. For example, it's 50 seconds. And then, in this case, we use JSON. So handle and the editor. In this case, we can add only it's okay, or we can put body dot homes dot, and this is an array, so we can use here to iterate the array, the start, and the provider. For the provider, we'll use a custom plugin. So we in here type, we will put out to provider in where we need the API and the stuff. So now we will put we will see the resource. Wait. Sorry. The resource. For the resource rules, we need the ID. That is the same that, well, it can be the same that Netatmo data source, but it can be different. For example, here the Netatmo data. The data source IDs. In this case, it must be the same that this ID, Netatmo data source. The subject. So in this case, we can put, for example, this data must be aligned to an ontology. But in this case, we have we don't we try to align to the vicinity adapters ontology. So what we will use here example.com / aurora / resource / thermometer. And in this case, the ID is here. We have body.homes. All the iterator. So here it will be ID. So Now we only we will put the properties of the thermometer. In this case, we need a predicate. For example, TPS. I will copy and paste it. And for example, the name. I has a name. So what is the object? The object will be $.name. We need a data type that is this is an string, so copy and paste it. And this is an attribute, so it's literal. And we can add for example, if all the properties here, and we can combine that's different data source. For example, if I have this API that provide the temperature, so this JSON is different to this JSON. So we can add this API and here have the weather with a different JSON format. And I will copy and paste it, but I forgot here and this. So we can combine the Netatmo data source with the weather API data source and work with the two data source. If the data is aligned to ontology, there is no problem with the semantic interoperability. So now we have the mapping. So we will see a demo. The demo, let's wait. Here is the service, the semantic adapter service. So, okay, now let's start it. We have this GraphDB, it's a database without information, and we have the following. Okay, the configuration is transparent for the pilot, so don't worry about this method. So we can create components if we use custom plugin. In this case, I create one component for the HTTP without OAuth 2. I was here, as you can see, there is no this here is not this plugin, so I will send it. And now here, you see. So we can create a task. For example, the ID, the name, capture thermostat information, and one description. This tag is focused on capturing data for a thermostat. So I will send it. And now to add here you can see all the information about the task. So I will send a post with the mapping that we created. And here we have a refresh, so there is no problem because the data is automatically updated. But I will do a put. So here we have now data with the device information for the thermometer, the weather. Here you can see the thermometer information. It's in Fresno, Spain, have a latitude, longitude. The weather station that here in Madrid, we have 12 degrees and have another latitude and longitude. This latitude and longitude is not the same because it's a different device. So in which context is the thermometer in this room? So now we can work doing some Spark queries. For example, provide all the information, or for example, I want to see all the information about the thermostat. So the thermostat has this ID. So here I can see all the information about this thermostat. If we only want to see some attributes, for example, the name, the time zone, and the country, for example, if I want to see the info, the room relation with this thermostat, I can see the that this thermostat is in my habitación, and this thermostat is in a custom room. If I only want to see the temperature, I can do a different Spark QL query. And if so, this information, I want to see the latitude, longitude, and the units of the temperature. I will put here the temperature value, the unit, the latitude, and the longitude. So I can see that in this weather station, mark 12 degrees and have this latitude and this longitude. Okay, but we will do some other complex queries such as, okay, I have this thermometer in one location and the other weather station in different coordinates, in different latitudes and longitude. So what is the variability of the temperature or if in my house have 12 degrees or less or more? So we can check here the distance of the two thermometers that I remember that is a different API, have a different API, but here I can check that my thermometer and the weather station is in a have the 25 kilometer of distance. I can, if I have more weather station, I can filter by distance. In this case, is 500 meters. So, for example, 5 kilometers, we return nothing because there is no. We only have one weather station. But if I put here 50 kilometers, I have this one. So, I don't know if Jorge, if you want to explain some of the programmatic adapter.
Hello, Juan. Do you hear me?
Sí, yes.
Maybe we can ask if there are any questions.
Yeah.
About your.
Yes, yes. Sorry.
Yes. May I?
Yes.
So, from what I could understand from your presentation, the Helio, well, the GraphDB is a GraphDB, nothing to it. The Helio is a service that you created, or is something that we
Yes,
can
Helio. Yes. Don't forget Helio. Forget it's a service for the UPM. It could be the semantic adapter, but you don't. Helio is the semantic adapter, but Helio is a service of the UPM. So it's the software. It's the software of the semantic adapter, but it's transparent. No, don't worry about the name of the. It's published in. If you want to try it, I can send you later the GitHub and try it. So there is no problem. Maria is working your ontology, so you can try it when the ontology is done. I can help you in configure the mappings and all the things. Don't worry.
Okay, thank you. My question was more to say that well, we have the mappings that you can provide to some service, and what from, well, this is very high level. Okay, so what it does mainly is to, at each refresh interval, it fetches the source of the information and it maps it according to the map that we provided on the properties and so on. That is it. Okay, and so you store it in a GraphDB that stores the all of that information. Is it so?
Yes. Well, for the mappings, I explain it a little quickly. Sorry for that, but Jorge,
that's okay.
Jorge created here a blog with some lessons for the pilots, and I will create here a lesson for creating mappings, and you can check it. And maybe we can put here some use case of the pilot. So for be more easy.
Yeah, okay. Maybe it's an issue on my part, because I am used to relational databases and NoSQL databases, but not yet to triple store databases, and so maybe it's some bias on my part.
It's a new concept, so I understand it. So no.
But what actually is stored on the database? So it's the mapping, or is the original data and the map?
No, here only the data. The mapping is stored only in Helio. Well, only in the, sorry, in Helio, no, in the semantic adapter.
Okay, and so what you store in the database is the data with the predicate, the subject,
the subject,
the object.
Predicate and object. Yes.
Okay, and then you can create. Okay.
So you can see here, that is all the data, the context. here, if you go to graph overview, we can see all the things. But
you don't have any. So, for example, if you need time-aware data, let's say it, you need to add a new property or new. That is the time, right?
yeah, if
Okay.
you need more different the data, you put it in the mapping, and all the stuff that you put in the mapping is stored here in the.
So in that case, you would need a new predicate that is time or timestamp or something like that,
Yes,
right?
yes.
Yeah.
And I think that the timestamp is automatically translate into or the format that you need, because if you can put here, okay, the timestamp SD is timestamp, and it's automatically translate into any date, any format that you want.
Okay, and in that case, you are already using some of the definitions from oral ontologies, like the sensors altitude,
Yes,
sensors coding country, and so on.
yes, but it's fictitious ontology.
Okay, that was my next question. Is that so? Is that does it have some kind of validation, or you can put whatever you like?
No, there is no validation at this moment for this moment, but I will speak with Andrea and I will.
Okay, just
ask him.
Okay, thank you, Juan, from my part.
Any other question? Okay, Jorge.
Okay, so taking over from where Rui left, then sorry, the semantic adapter, or this declarative adapter, has some things that are making your life easier, but the trade-off is that some things are fixed, like for instance what Rui was mentioning, that it's is using a triple store for storing the last values. Nevertheless, that should be transparent, so it shouldn't be very difficult to use in the end. And you can define then just as Juan was showing, the mappings, and store this configuration, and everything should work. However, there is a different approach that we've taken to give more flexibility, because, for instance, there are limited number of providers in the semantic adapter which can be extended. Like, for instance, there was HTTP REST, static files, and so on. You can create plugins, but for that you need to code and extend it. Or you can use this programmatical adapter, which is not, it is not end product itself. It's a framework, meaning that you need to do something. You need to code something into it in order to have the adapter ready. We chose a popular node development environment, Node-RED, where you can code just by dropping boxes. And also we created, this image is not so visible, but you can, when you install the programmatical adapter, that, by the way, will be possible to install just by using the Node CLI. So like we presented 2 weeks ago. So these 3 boxes on the bottom left side will be ready for you to drag and drop, and you will be having a lot of automation of, like, for instance, registration of devices will be automated, receiving requests will be automated, making requests will also be automated, and your work will be basically to define a flow. Node-RED, the synth Node-RED, it is called flow, what you are coding, let's say, into quotes, coding. And these flows will be just accessing your data and bringing it to the Node-RED. Of course, we will explain how to do this with a whole example, since from the registration side till the point where you are able to get data or to post some data. We chose Node-RED because it's open source. There is a lot of support, so you don't need to code actually. For instance, MQTT client, it will be built in, so you don't have to do that. And for instance, there is even Juan was showing Netatmo. There is also a client for Netatmo and so on. There are different integrations that are already available, and it's very, very flexible. So you can mostly create almost anything. So in 2 weeks, we will show how to download this programmatic adapter and how to make some simple integrations, like for instance, could be MQTT or the same Netatmo that Juan presented today. If you have any questions on this point, if not, we will of course go over it in 2 weeks in the next session. Okay, then I'm giving back the floor to Juan.
To finish the session, it will be very short, but if you have any question or something, write me an email, and I will put this video and these slides in the Aurora Cloud, and I will put some links with the blog and the Semantic Adapter for if you want to use it, you can feel free to use it. And just remember the blog for the for you. Here you can check how to register an organization, how to configure your account, create an access point. So we will add more information in this documentation. So if not, there is no question, we can finish the session. Okay, so